This is the 11th EU-India Smart Grid Workshop and the second in a series happening on the virtual platform. And this cooperation has brought in very rich experience sharing between Europe and India. And some of the projects are now real projects which are happening. And now we have a high-level platform for experience sharing. And today we released a handbook just a few minutes before we released the handbook for replication, cost-benefit analysis, and scalability and replication analysis. So this, I believe, will help a big way in replicating the projects which we have done in Europe, the ones which are relevant to India, and scaling up them, replicating them in Indian context. So I thank the European Union and the DG Energy Office of European Commission for this long relationship and taking this initiative forward. In fact, under Horizon 2020, when the call came for projects to be executed in India, the rest of the world was shocked. And that collaboration is a result of this EU-India Smart Grid Workshop, which started in 2015, the first one at Nice. So both the stakeholders from the Europe as well as our partners, our members from India, been constantly supporting this, and we have reached a level that there's a energy and climate partnership between European Union and Government of India. Also, all the agendas and the topics which we are discussed in these workshops are actually transforming into government programs and projects. I'm very happy to note that. Without taking any more time, let me extend a very warm welcome to Mr. Florian Ermacora, the head of Units International, Directorate General of Energy at the European Commission. And thank you very much for taking time out in this complex days in Europe, taking time out of your official duties and coming to address this workshop. We also have Mr. Amal Sinha, who is the Executive Director of PL and BYPL in Delhi at the inaugural session. And we'll move on with the first session, which will be on the handbook, which we have just released. The members from the EU-India high-level platform on smart grids will be part of that. And my colleague and friend, Mr. Arun Kumar Mishra, Director of National Smart Grid Mission and co-chair of this EU-India high-level platform. Warm welcome to you, Arun, and Sweda, who is the head of FSR Global, and also Thomas Gomez from Comillas University, who was a knowledge partner who worked with us in preparation of this handbook. ISGF was honored to be part of a knowledge partner for this handbook. And from our team, Rina, Sudasata Kundu, and others have worked on this. The second session, we will have Sweda moderating it, and we have Madam Anjali Chandra, member of Punjab Electricity Regulatory Commission. A warm welcome to you, Madam, for agreeing to join here. And Professor Anup Singh from IIT Kanpur. Welcome to you, Professor Singh. And Debajit Palit, Director of at the Energy and Resources Institute, TERI, and also Adul Kumar Bali, Chief General Manager at NSGM and PMU. Warm welcome to both of you. And Mr. Ganesh Das from Tata Power Delhi Distribution. He's been part of most of the EU India Smart Grid workshops which have both in India as well as in Europe. And Matthew is the Matthew Cray, International Relations Officer at the Directorate General of Energy European Commission, is the one who conceived of this series of workshops and been a pillar of this program. 7 years we have the pleasure of your support and help in taking this to this level. And Matthew, thank you very much, and warm welcome to you for arranging and designing the two-part EU India Smart Grid workshop, the 11th workshop, part A today and part B tomorrow. So without taking any more time, let me invite Florian Ermacora for his opening remarks.
Many thanks, and many thanks for the invitation. I'm really glad to be here virtually. I'm looking forward to the moment where I see many of you physically. I hope that's not in the too far future. I'm very delighted to participate in this workshop, and I would warmly welcome and greet right away Mrs. Kandra. It's great to be here with you, and I would also like to welcome very much Mr. Amal Sina. I appreciate your presence here. And we in Europe, of course, for the moment, we have a real crisis, I would say, which is a political crisis, but to some extent also an energy crisis. I must say, very much related, of course, to natural gas, but also electricity. But we think also in the moments of the crisis that we are going the right path towards getting more renewables into the system. And so from that point of view, even if we have a big even geopolitical crisis, we believe it's very right what we are doing here also, and in particular also with the cooperation with you on the topic and doing it with you. We are happy, and I explain this in a moment. And I'm happy that this is already the 11th edition of this Smart Grid workshop, which delivers really, and this concrete action. It's not just talking; it's really concrete action, and that's the most important thing. And we had all over the time the strong support of the India Smart Grid Forum, both in starting and developing this series, which is so important. All this is framed by our overall energy dialogue between the EU and India, which we have initiated already in 2016. And I participated on 1st of December last year in the energy panel, the EU-India energy panel, and I was really impressed by the commitment of all sides of pushing things forward, both on energy and climate. This is interlinked. We have of course, still the climate crisis. That's for sure. And we have also with the energy security issues. We are always coming back to the same points. We need to accelerate the deployment of renewables, of energy efficiency, and we need to integrate renewables better. And this is one of the key themes of our partnership overall. Besides, of course, and related to the financing and to new energy carriers like green hydrogen, having interconnections, of course, and also a dialogue on just transition. All this is very important. But in this, a particular priority is really to support renewable energy deployment, and we are very appreciative of the Indian objectives of your 450 gigawatt renewable energy capacity to be installed by 2030. And we do not think that this is possible in an efficient way other than through a proper market framework and the right infrastructure. And when we talk about the right infrastructure, we mean, of course, smart grids at all levels. That's really the experience over many years in Europe, that we need to have a functioning energy market, decentralized energy production, competition. We need demand response systems. We need to have a good balancing system, optimizing really the local energy systems. That's a very important element also in Europe. And it always comes down to the question to have the right infrastructure in place. And this is about smart grid infrastructure, as I said, at all levels and the respective applications. So from that point of view, what we are doing here, what you're doing here, is crucial, important to achieve these energy objectives in the most effective way. And from that point of view, I appreciate this workshop today, and particularly, of course, this specific product of our corporation launching now, the Smart Grid Replication Handbook for India, which has been developed over some time together with the Florence School of Regulation and the various knowledge partners here. And a particular thank there to the Comillas University in Spain and the Indian Smart Grid Forum in cooperation with PwC in India. That's really an excellent result, and these are the sort of tangible things we are looking forward. So that's super important to have this handbook. And we are also very and particularly happy that India's Ministry for Power and the National Smart Grid mission there, the director, Mr. Mishra, provided a forward to the handbook and is also actively participating in today's workshop, because we need this kind of support to make things happen. So from that point of view, very important to have this handbook, and now entering the phase of disseminating it, having an uptake of it, and bringing it to practical use. So that's the very purpose of this. And let me really thank the India Smart Grid Forum for this continuous support to our corporation, and a special thanks again to the Florence School of Regulation and our friend Director Clachon for supporting this cooperation. So with these words, I wish you really a very fruitful workshop, and looking forward to the important results of this work. Thank you.
Thank you very much, Mr. Marcora, and look forward. The next workshop, 12th workshop, will happen somewhere in Europe. We hope the situation will be normal by then, both from the perspective of the COVID-19 as well as from the war issues. So we really look forward to having the next workshop in Europe. Thank you very much for your encouraging words. I now invite Mr. Amal Sinha for the opening remarks. Over to you, Mr. Sinha.
Thank you, Mr. Reggie and ISGF team. I think it's a great honor to open the remarks here. I think European experience has been very, very crucial for us as a developing country. We have a lot of challenges in terms of power distribution in the existing and the conventional way. Now, the fast pace of transition which we are going to see, and which is already there to a large extent, it is knocking our doors in terms of renewable integration, the bidirectional flow of energy, the EV adoption, which is coming in a big way, the other aspects of energy transition, which is related to smart grids and smart metering. All of this is being taken in a national mission mode. There is a very, very strong government direction push and a serious push to all the distribution companies across India to drive initiative in terms of loss reduction, smart metering initiative, renewable integration. There are various statutory directions and statutory targets. So the whole thing has started moving in the right direction, and with the full support of the government. And here I think collaboration and learnings, particularly from the European experience, would be very useful. And I'm quite sure this handbook would give us new thoughts and new learnings for us, particularly the way the renewable integration has happened in European countries. the way the vehicle to grid functionality during the off-peak hours, and how the solar rooftop projects have been used to manage the peak loads. These are something very, very interesting insights which we are looking for. As a progressive utility, BSCS has done various pilots with companies in Germany, France, Italy, and also Norwegian companies. And we had trying to gather experiences on a bilateral basis. I'm quite sure the handbook is a result of various activities undertaken in technological advanced areas of the Europe, and we are looking forward. And I'm very hopeful that this handbook would be very useful for in India and for the industry as a whole. Thank you so much for making the opening, giving an opportunity for the making the opening remarks. Thank you, ISGF. Mr. Reggie,
Sir, thank you very much, sir, for sharing your insight with us.
Yeah.
Now, I would like to extend a very warm welcome to Mr. Jean for vote of thanks. Hello.
Yeah, Professor Glashan, it's for you.
We cannot hear you, Professor.
Want me to speak?
Yes, the floor is yours, Professor.
Okay. Ladies, gentlemen, I am very happy seeing with you that India and the European Union are sharing their respective knowledge in a new body, this Smart Grid Replication Handbook. Smart grids have gained maturity in many domains and very significant footholds in others, as with smart cities, electric mobilities, mini-grids and microgrids, peer-to-peer exchange, demand response, etc. As I said a few minutes ago, India, with its world-famous cohorts of engineers and its top managers, has much to teach us, the Europeans, about the many futures that can come. And we, the Europeans, with an advanced energy regulatory frame and a demanding climate policy, we have many ideas, many tools that need to be tested and challenged. And I was referring to the chapter 4 of this handbook about CBA and SRA analysis, and it's really a wonderful, practical conclusions of the best things we have done on our two sides. And to conclude, I will repeat that being born in Florence, our school was being reborn in New Delhi as FSR Global, and we are very, very happy working so closely with Indian Smart Grid mission and of our outstanding cooperation with India Smart Grid Forum and our very dear friend Reggie Pillai and the PricewaterhouseCoopers India. And for the handbook, we graciously acknowledge the financing by the European Embassy in India and the European Commission, DG Energy. And let's go for many years of cooperation because the challenges we face are really outstanding.
Thank you, Professor, for the vote of thanks. And on that cue, I think we will move to the next part of the agenda, where I, along with the co-chair, Mr. A.K. Mishra, and our knowledge partners, Sudha Satta from ISGF and Professor Thomas Gomez from Comillas University, will present to you about the philosophy of why the platform was set up, and of course, details on the handbook itself, what we have to offer you in about 125 pages of, I hope, a light read. But yes, and post that, we look forward to listening to fellow experts from the field on your opinions and suggestions and sort of how we can co-build this going forward. So just give me a couple of seconds to launch my presentation, and then Mr. Mishra, the floor will be. I'd now like to invite Mr. Mishra, who's the Director of the National Smart Grid Mission, to say a few words on his participation in the platform and the experiences from it.
Hello, good afternoon, and thank you, ISGF Smart Grid Forum, for this workshop and inviting me, and of course setting up this platform to EU as well as Indian side, ISGF. A smart grid is something which is close to my heart, and when we started our journey for setting up a India Smart Grid Task Force as well as India Smart Grid Forum, it was always a challenge to, bring out the best and make, while it was easy to get technology perspective, it is always difficult and a learning exercise that how the technology makes impact on the ongoing process as well as the on ground problems. So National Smart Grid Mission, we are always committed for expansion of a smart grid within India with the transformation of utilities. So when an opportunity came around me that yes, we can collaborate for learning from experience of Europe, I was happy to accept it, since a series of workshops were undertaken, and my refrain from the beginning has been that while we have to find our own answers, what are the questions which can be explored, what dimensions which can be compared, and what has been across the globe, it will always be a accelerator of our learning as well as allow us to learn from others' mistake. So this workshop, this platform is set up for that, and I look forward to the platform's continuity in terms of while the document is released based on the series of workshop. Unfortunately, due to COVID, a lot of expansion and exploratory activity within India in terms of CEOs interview, in terms of visit to the actual pilot sites, and integrating those experience remains to be undertaken. And I look forward to that in moving forward, we will be able to integrate those activities as well. And how it will make a difference is, as Sheen was rightly mentioned, that the document contains a cost benefit analysis tool, which helps you consolidate what are the smart grid can do for a utility. And I rather look forward to the document triggering a second set of workshop debate initiatives, some of which is not necessarily led by India and EU, but they are led by NSGM and other entities as well. So that what we come out is the next level of CBA, which is parallelly being handled at CA as well. And we have a live cost benefit analysis tool, which takes care of the nuisances of Indian regulatory atmosphere as well as the priorities of DISCOMs. Having said that, I will definitely confirm that this has been a learning journey, and I look forward to a continuity of these kind of dialogue and exchanges, because we we can import technology, we can always certainly mimic processes, but smartness is about knowing your problem, solving your problem, And if you focus on solving your problem, you will have an early and fast traction across the ecosystem and from multi stakeholders. And that's an area where these kind of dialogues are much more important than a standalone procurement of technology deployment on a historical perspective and not really learning and changing along the way. So I look forward to the liveliness of this platform and of course a further learning and continuity. Thank you.
Thank you so much, Mr. Mishra, for always being our cheerleader in making this work a success. And definitely, most of the points that you mentioned are incorporated as suggestions in the report, but we look forward to actually implementing them, hopefully, even as early as next month. So with that, for those of you tuned in to understand a bit more about what's the kind of work we did, as Mr. Mishra rightly pointed out, it's been a collective effort of over 30 plus experts from both European Union and Indian side in making this body of work a success. It took us a lot of deliberations through workshops to first understand, okay, within the universe of smart grids, what are the key parameters that we should focus on? And particularly in the context of India, how does this change? So I think we had to go back to the drawing board and sort of put down these basic questions before even we dealt with the details of smart grid projects in India. So I think that itself was an interesting journey for all of us to bring our experiences to the table. So particularly, I would like to here thank the European Commission for giving us this opportunity under the EU-India Clean Energy Climate Partnership Program and for their support in making sure that this actually took off, even though we were all facing a crisis such as the pandemic. And for the Ministry of Power, the National Smart Grid Mission, who have been our continuous partners in making sure that these discussions were fruitful and also contributing actively from the lessons learned from the Indian side. In addition, of course, we had utility representatives, regulators from the Indian side and the European side who were an active part. On the academic front, we, the Florence School, were chairing the platform with the support of our European partners, Comillas University, who have been very instrumental because they bring the body of work focused on the methodologies from Europe and how it could be adapted to India, and our Indian knowledge partners, the Indian Smart Grid Forum, which sort of helped us apply it to the Indian projects. So I think it was a collective effort in making this a success. So in terms of what to expect from the handbook, what we have tried to give you is, of course, an overview of what is happening in the European Union and India when it comes to smart grid projects. So there is a repository of information that you can look at. Of course, it's not exhaustive, but indicative enough of the kind of applications that you see. And importantly, what we try to do is develop a framework on how to select even the use cases that would be pertinent to India. Because there are so many, and but if you look at the pattern of implementation, there are some of the sort of top contender use cases that come as a recurring application in most of the projects. So it was interesting for us to see how use cases were applied in the European side and to see how it was done on the Indian side, and then sort of overlap them one over the other to determine how it sort of translates to the Indian subcontinent. Then, of course, once we had the use cases in the project, our next challenge was how do we assess these? And we have used two methodologies here, the CBA methodology and the SRA methodology, which are explained both theoretically as well as practically on how to apply to projects using the data that we had got from the projects, and sort of what are our key takeaways from assessing these projects in EU and India. And of course, lastly, we do give specific lessons that would apply in the context of India, and that would help with the smart grid replication journey of India in a faster mode. And so this is sort of a quick overview of what to expect from this handbook. So if you scroll through the different chapters, you'll be able to sort of zero in on these particularities. With this, I would now like to invite Professor Thomas Gomez from Comillas University to run us through the technical aspects of the report. Thomas, over to you.
Thank you very much, Shweta. Good afternoon. It's a pleasure to be here and to try to share with you our traveling through this project that has been quite successful, I would say. And the handbook is a good product for the future. The first, in the project, we covered different phases. The first one was how to concrete in some way the number of projects or the number of studies that we can demonstrate in a handbook, because the smart grid is so wide that it's difficult to select which are going to be the use cases to analyze in particular. Therefore, we started with a long list for our experience in the European projects, and we use a methodology for trying to classify those projects and score the projects in terms of the benefits. And for that, we use the expert knowledge from the platform. And also, we understood which are the Indian projects that are running right now. Therefore, we mix both information with the score system and with a methodology for that, and we ending selecting 3 main use cases that are being studied in detail. The 3 main cases, next please. Next slide. Shweta, you can pass me the slides? Yeah, okay. The 3 use cases are the demand response and consumption optimization from the end user point of view. The second one was the low voltage network supervision and control, including the advanced metering infrastructure. And also the final one was the medium voltage grid automation and reconfiguration. For these 3 cases, first we try to implement what we call in Europe the CBA methodology that has been implemented through guidelines given by the European Commission Joint Research Center. This has been quite successful methodology that we implemented in all the European projects that we are running. And in this case, the idea is going from technologies to functionalities and finally assessing the benefits of those technologies together with the cost. It is true that there are some issues that can be monetized for the investor profitability, for the society profitability, but there are others that are not monetized itself, but that are important for the societal welfare. Therefore, the methodology is quite comprehensive, and we have applied that. The next slide. The use cases that we took from already how this methodology, to demonstrate how this methodology were implemented, is in terms of demand response. There were cases from Sweden, also from Portugal. In the case of network, low voltage supervision and medium voltage supervision, we took some cases that were done in Malagrotta and Rome in Italy. Next slide. Just for the sake of illustration and the type of study that is done under CBA, for instance, here we compare 3 different options for demand response in some way. The first one is based on home energy management systems in active houses for energy efficiency. The second one is kind of social network based on mobile phones that they have apps for sharing the experiences between customers in terms of energy efficiency, CO2 reduction of the bill. And the final one is much more advanced because it's the aggregation of low voltage consumers for providing secondary reserves in the flexibility markets. Therefore, we understood where were the benefits, the costs, and in some ways, we got positive net present values for the benefits, but in others were so negative. For instance, was clear that in the case of, for instance, automation in houses, the consumption in the houses and the behavior of the number of consumers in the houses was a very important metric. Because, for instance, where there were 1 or 2 people living in the house, the flexibility was much higher than when it was a whole family. Therefore, depending on these behaviors, there were some positive results and some negative results. Therefore, that is very interesting because it was very depending on the case studies and the situations that were considered in the study. Next slide. Well, what are the conclusions that we got from this case studies that we analyzed? First, regarding demand response, there is a new business opportunities, mainly regarding how to obtain flexibility from end users and from aggregators. This is something that is quite active and is quite innovative. There is also a very important issue related to the incentives that the consumers perceive because of participating in those services, or even for designing dynamic tariffs. These are very relevant in terms of dynamite, in some way foster the participation of consumers. And also the benefits are very case dependent, depend on the type of consumers, depending on the consumer behavior, and also on the tariff structure. Regarding medium voltage and low voltage grid automation, it's clear that the benefits for DSOs are very, very clear with the new infrastructure because they are going to provide much better service, they are going to increase the revenues, but also for the consumers in terms of security of supply and reliability and power quality. It's clear also that the level of automation depends on also the case, very case dependent, and should be very carefully analyzed depending on the networks, rural, urban, and different situations. And also in some cases, we detected that for pilot projects, the first CVA was negative, but that when you scale up the project due to economies of scale, the CVA can become positive. Therefore, that is also relevant. Next slide. Okay, I'm going to pass Sudarsata.
Thank you, Thomas, and a very good afternoon and good morning to all of you. And for these Indian projects, actually, we have considered under the LVR MB automation supervision and control from the smart grid projects that has been granted by Government of India. And due to limited availability of data, we have considered two projects. One is from Uttar Gujarat Which Company Limited, and UGVCL, and another was the Tripura State Electricity Company Limited. And we have considered all the smart grid implementation, smart grid technology that has been implemented under these two projects from AMI and also assess the communication infrastructure, the peak load management, and also the outage management system. And if you see from the data that we have gathered from the utilities, we have seen that there is a significant improvement in various KPIs such as SAIFI and SAIDI. And there is also over a period of 4 years. And the CBA analysis shows that the payback period was in fact very short, of 3.5 years, with the investment that has been quoted by the utility and the benefits that have been accrued by implementation of this smart grid technologies. One is the Tripura. In the Tripura, there is a AMI along with the data concentrator units, and the whole AMI infrastructure has been implemented along with the peak load management system, and the benefits accrued by through the AMI implementation are close to 37 crore a year. So if you see from both these Indian projects that we have considered is that with the implementation AMI, there was a significant improvement in the profit that can be generated or the savings that can be generated by the utilities in terms of better asset management and load management, etc. Thank you. Next slide, please. Yeah, Thomas, please.
Okay, I will continue. Yeah, the second methodology that we apply and is very relevant because many of these projects are pilot projects is what is the aims that you have to take into account when you scale up the project for large scale deployment. Could be at the nationwide or could be at the company-wide project. That is very important, how to scale up that. And also replication, that is we call scalability and replicability. Replication in terms of to reproduce the functionalities that you have in the demo project, but in different type of network, different type of regions, and different environmental constraints. And in that case, we develop, we use a methodology that has been also developed under the European Union research projects under the Bridge initiative. And this methodology is specifically for smart grids projects. And in this case, we have 4 dimensions: the functional and technical dimension, the information and communication technologies, the regulatory issues, and finally, the stakeholders' point of view. And for this methodology, we have to take into account that there is an architecture model for smart grids with different layers, right? We have the component, the communication, the information, the function, and the business layer. All these aspects are considered in the methodology. Next slide. In this case, we have the same three use cases: demand response, low voltage supervision, and medium voltage grid automation. And here we use also different projects, European projects with different demos in Germany, in Portugal, in Sweden, in Spain, and Czech Republic in particular. This slide. Just for the sake of illustration, I'm taking here the functional scalability and replicability analysis for the low voltage grid supervision and control. And in particular, for instance, we can see that in the Grid for You project, in the Swedish demo that they were analyzing supervision and operational problems and phase unbalance in low voltage network, there is a kind of sensitivity variables, sensitivity parameters that they are impacting in the replicability of the pilot, which are related to the type of network, the number of distributed resources, the level of loads that you have in the system, and the level of electric vehicle penetration. Then you said, what are the KPIs that you will consider? In this case are load factors and over voltage in some buses in the network. And finally, you get, after analysis of these issues, you get some conclusions and lead results. For instance, here what we studied was how energy losses depend on the load in the system, the imbalance in the system, the strategies for charging, slow charging the vehicles, and also the penetration of distributed generation. In this case, PV, depending on the levels of PV, the impact of energy losses are going to be much better or lower. There is another case that I'm not going to go in detail, just for you to know, that is related to how to control voltages with different strategies in the low voltage grid when you have a high level of monitoring and supervision. Next slide, please. Okay, I pass the word to Sudasata.
Thank you, Thomas. And for the scalability and replicability analysis that we carried out for the Indian projects, if you see the scope that I already mentioned, is the AMI implementation, peak load management, and output management. And the sensitivity parameters, or the parameters that has been monitored on that, is the loading of the network, phase balancing of the network, the type of the communication infrastructure. Because when we are going to scale and replicate this same infrastructure or the same technology in other states or other utilities, we need to understand what is their impact, what are the KPIs, the key performance indicators, and how they have improved over the time with the implementation of these smart grid technologies. So based on the lessons learned, how we can implement those technologies there so that accrue the same benefits or more benefits that has been accrued over the smart grid pilot projects. So if you see for both these projects, UGVCL and the Tripura Electricity Supply Company Limited, there is a decrease in with the AMI implementation. Obviously, the load balancing was one of the major issues that has been solved. And there's a peak load management. There is a peak load management. There is a better peak load management by the utilities with this. There was a reduction in the AT&C losses, most over the transformer failure monitoring and everything, asset management that has been carried out at a better, at a much better level by the utilities with the implementation of the AMI. So with this lessons that we have learned and with the benefits that we have accrued in those two projects, it is viable that we can replicate these projects along with both the whole of the AMI infrastructure, along with the other technologies like PLM and outage OMS. And we also need to look into the things that how these technologies can be integrated together to get the benefits at a much larger level. Thank you. Thomas?
Okay, just for finishing this, the technical part, what are the main conclusions for this scalability and replicability analysis? Regarding technical and functional analysis, for instance, in unbalanced network, when we study the voltage control strategies for PV host and increasing PV hosting capacity, the better strategy was what we call wide area control based on the OLTC transformers with data from smart meters, better than using only local control of PV units. In terms of medium voltage grid automation and reconfiguration, network automation in urban and suburban areas, provide benefits in terms of reliability. But it's interesting to know that the automation, the level of automation should not be very high. Just with 20 to 40% of the elements under control, the benefits are almost the maximum ones. Regarding the medium voltage network reconfiguration and increasing hosting capacity, it's important that to know that the limiting factor are typically over voltage, not so much overloading, and that is mainly due to the type of networks that we were analyzing. In terms of ICT, the ICT is very, very case depending on the situation that you are trying to demonstrate in the demos. And that depends on the actual needs and infrastructure. For demand response, side-V communications with controllable loads is something that is quite extended and is a good solution. And for low voltage grid monitoring and control, there were also implementations in the cloud that were much better than using dedicated local devices, because in this case, reliability is going to be deteriorated in some way. In terms of regulation, it is clear the importance of having dynamic or time of use regulated charges, retail tariffs for promoting flexibility, specifically for those loads that are more flexible, like charging electric vehicles, for instance. In terms of implementing automation in low voltage and medium voltage networks, it's important to acknowledge in the DSO revenues how they are going to be benefit from that and establish specific incentives for doing those implementations. Regulation of smart metering is quite relevant in terms of deployment, functionalities, data management, and data assets. Because in this case, those smart meters are the input for many other functions that are depending on that. Therefore, standardization here is also very, very relevant. In terms of medium voltage grid automation, it is clear that there are now very nice best practices based on very good experiences of operators, and that is quite easy to go ahead with that. And finally, the view of stakeholders is very relevant when you have end-user programs and user participation. And that is very relevant in this case for demand response, for instance. I think this is my final slide. And Sweta,
Thank you, Thomas and Sudhasatha. So moving forward in the presentation, I'll focus on the lessons for India that was collectively sort of analyzed based on all the experts that contributed at the platform. And what we have done is we have tried to segregate it into 4 different buckets from technology perspective, from finance perspective, from the policy regulatory perspective, and of course, on the social acceptance perspective. So I'll just run you through some of the key observations that we have had through the last 15 months of discussing this topic. On the technology front, as picking up from where Thomas was mentioning his previous session, of course, to decide the optimal level of automation, it was first important to analyze how actionable and available those options are, especially looking at it from a DISCOM's business case perspective, especially in the context of India. Second, the customer willingness to participate, I think, needs to be assessed, and we need to sort of see how to sort of involve them at the various levels of the projects that we would deploy. For utilities, what would be important is to build a vision both at the decentralized and centralized level of planning, because just one-off applications or either or would not sort of help in the long term. So it would be important to sort of look at it from both sides. And of course, something that we came back to the basics was, of course, we cannot deploy all of the technologies in one go. That would be economically not feasible. What we could do is build technology layer by layer, and therefore sort of have a more linear development. But at the same time, keeping in mind that innovative pilot tests need to be conducted to check what can be deployed, and this can happen in parallel. And that's precisely why platforms should be available to exchange learnings for faster replication across India. Coming to the finance part, of course, what we need to focus while looking at solutions, smart grid solutions in particular, is not just the monetary consideration, but whether or not a particular problem is being challenged. So it needs to go beyond just looking at the numbers on an Excel sheet. And as a suggestion to that, what would be more suitable is if we could come up with a set of KPIs that could be used as a reference framework based on which projects or distribution companies in India could evaluate the impact of their projects. So going beyond numbers again. And something that was a challenge for us in conducting this report was also the non-accessibility of data or the regulatory roadblocks in sharing of data. For instance, India does have a very good case study and a project on demand response, but we are simply not able to evaluate it because data was not accessible, whereas the other use cases that we did focus on, we were able to because data was accessible. So I think that is a roadblock that we need to get past if we need to speed track our process. And lastly, of course, with India, it's not one size fits all. What we need to always evaluate is how this can be applied in different states. And probably it's not always best to focus on the best performing states in terms of the grids. It can also start with states that need this smartness to be integrated into the grid to sort of catch up with the other states. So we need to look beyond the usual to see how we could deploy it in the larger part of India. And of course, as a byproduct of this, what needs to be parked is a chunk of investments need to be made in capacity building, because in order to scale up and do anything, we need the workforce which needs to be well equipped with understanding the challenges that comes with implementing smart grids. On the policy and regulation front, of course, what we do intend and through the methodologies that we propose, what we do assess is the trade-off between societal benefits and, of course, economic benefits to the different stakeholders. Particularly here, it's more beneficial for the distribution companies because they would be the ones implementing it. And local regulation, especially in India, both at the state and the federal level, should look at long-term vision, because just setting up one-off projects would not help. What we need to sort of enable is having this long-term vision, thereby bringing in also with it long-term investments. So that would help with the continuity of all the good work that's going in by some of the experts that are doing a great job. And of course, as again reiterating, we should move beyond one-off projects and go for a more KPI-driven planning approach, which would also give all the stakeholders involved a sort of a incentive to work towards that and sort of develop a business case in trying to bring in a more strategic way of investing into smart grid projects. Lastly, on the social acceptance front, what was, of course, derived is that we need to find and come up with different incentives for customers to participate, because at the end of the day, they're sort of the ones who would be ruling the future energy sector, and in some parts already are. And today, customers are pretty tech savvy, so we need to sort of bring them in. What particularly is a challenge in the context of India is the diversity of our customer base between rural to urban. So that challenge needs to be assessed region by region level. And of course, the other aspect of it is also to sort of de-risk projects for those who want to implement it by sort of giving a long-term in contracts, a sort of long-term vision of how their money could be put to better use. And of course, something that would reassure those of them bringing in new technologies, if we could have more open standards leading to better solutions in a more streamlined manner. So these are some of the key takeaways that we have got from the experts that participated, and also based on the surveys that we have done. In conclusion, keeping in mind that we don't want this effort to be a one-off attempt, what we propose is to sort of set up a National Smart Grid Observatory in collaboration, of course, with the National Smart Grid Mission and other Indian stakeholders. Particularly what we intend or would be the wish list for this observatory is, one, data sharing. I think it's super important for us to have reliable data, not just any data that could be used by any research team in India to assess projects across India, because there's so much work to do and so few of us having the opportunity to do it. And for that, an open access platform would be much needed. The second is, of course, we started off with 3 use cases. The idea is to sort of monitor and sort of develop and see how different use cases are being implemented in India and move forward to sort of assessing them. But at the same time, taking forward the findings of this study to the central level, going beyond the federal analysis, and seeing how that would sort of change or can be replicated as it is in the state level. So that's sort of the wish list for the Smart Grid Observatory. And of course, we would love to continue this platform into the second year and third year and so on and so forth. And as Mr. Mishra very rightly pointed out, it did start off as initiating the platform, but the more that can join, the merrier. And the idea is for it to benefit all the stakeholders in India and to take away the lessons that we collectively learn from the projects that we implement. So with that, if you have further interest in reading the 125 lovely pages that we put together, please do download the report using this link. We will also share it through social media channels and newsletters, or you could simply just Google this and you should be able to find it at the EU CECP page. And if you have any questions about how the platform or what we intend to do in the future, definitely you can get in touch with Matthew, Edwin, or I, and we will be more than happy to run you through the details and to involve you in the kind of work that we do. Thank you so much. With this, I would like to take forward the discussion to the next session and sort of invite our discussants here today to give us their view on how they found this work that we have done useful, and probably give us some suggestions on how to improve it going forward, and also sort of do pointers in things that we might have missed. So with that, I would like to now invite Ms. Anjali Chandra, who is from the Punjab Electricity Regulator, and coming from the Florence School of Regulation. We are super excited to hear your views, ma'am. So the floor is yours. We are not able to hear you. I think you'll have to unmute yourself.
Thank you, Shweta, and a very warm good afternoon to all of you. I'm delighted to be a part of this discussion. And, you know, the handbook, the features of the handbook which you have described to us would be very useful in promoting the concept of smart metering and smart grid from the regulatory point of view, as well as from the DISCOM point of view. You know, it is always difficult for the regulator to pass long-term investments in the short run because of the cost benefit analysis, because you know, we only do a financial analysis. How to do the societal and environmental benefit analysis that would give an insight into that. We all know that it is you know, of benefit, but how to do the analysis would be great, and you know, how to scale it up. Well, you know, the utilities. Hello. Yes.
Yes, ma'am, we can hear you.
Yeah. So, you know, the technical replicability and the ICT replicability of projects, and at what scale the utility should start would be very important for from a regulatory point of view. You know, this utility does not understand where to start. Should it start replacing all the meters, or should it start with a pilot project? But as you all know, the consumer rules have said, consumer rules by GOI have said that all new meters should be smart meters. And when the utility is buying all new meters as smart meters, then when you are installing these new meters, they are spread over the state. They are not, you know, concentrated in one area. So, you know, whether we should go in for that, or do, you know, for having KPIs and evaluating projects, it would be necessary to concentrate these in some areas. So we have asked our DISCOM to try and do a cost benefit analysis and install some meters on the high value customers, so that we are able to find out the benefit of these in commercial areas, in industrial areas, and in residential areas. What will be the benefit? Benefits are known, but how much has been the improvement? You know, the key performance indicators, how will we get these indicators? And secondly, how much is the customer acceptance of these meters? You know, that is very important, because if you look at the ground reality, we had installed electronic meters outside on pillars, And during COVID, many consumers have removed those meters and put them inside their houses. So would they be, ready to have smart meters installed on them? Obviously, when you put a meter inside, you may be doing some, something with the meter. So consumer acceptance and behavior in such cases, how to tackle that would be very important, especially in the border areas, in the areas where, this is taking place. And definitely, we would also like something on what should be the O&M costs for these smart meters. One is the communication costs, then the manpower costs, and other costs associated with smart metering in operation and maintenance. One is the capital cost, we understand. The other is the operation and maintenance cost. So if we could have an input on those, and also on what technology of communication should they follow. So in the, should they have different pilots on different communication technologies, or go by what, because the obsolescence in communication technology is very high. So, by the time you do establish a technology in your area, it moves ahead. So, backward integration and forward integration in the technologies, how to go about that would also be, should be part of your handbook on how do we go about it. And, like I was very happy with the, that we could have dynamic tariffs for this demand response. We already have TOD tariffs because our meters are electronic. But since we'll be getting 15-minute data through these smart meters, then how to move to time of use tariffs, that would also be required. And, data storage and data analysis. How to go about analyzing that data. Data will come in huge amounts through smart meters. So the DISCOM should have the capability of analyzing that data. And, what kind of capabilities are required by the DISCOM officers? What kind of personnel should they deploy for the data analysis? Because smart metering is all about data analysis for load forecasting, for power procurement, for reduction of losses, and for various setting tariffs. So I would say that what kind of storage should they have? How much should they invest in storage? And how to analyze that data would be important from a regulatory point of view. So that, we can unlock the benefits of smart metering. We do not remain at just installing the smart grids and smart metering, but we unlock the benefits for demand response, for various other MVLV, automation, reconfiguration. We all know what we can do with this, but unlocking this benefits requires real capacity building by the DISCOMs. That would be, in my view, very important for us. That would, and how to integrate the data which comes from the head-end systems to the meter data management system, and further to the legacy billing and billing software. We all have billing software, so how to get it integrated? I know the provider of that communication, and the entire system should be able to integrate it with the billing or legacy billing software, but it takes a lot of time to do that. So if how it is being done in the European Union, and if we could have some inputs on and meter portability, like all smart meters should be on open source and open database. Otherwise, we have faced a lot of interoperability issues in electronic meters. The same should not occur in smart meters. We should have standards which allow portability across various systems, so that the data is available in a given format, which can be utilized by the billing software and other enterprise solutions, how to integrate this data with other billing solutions. I think these are a few points I would like to say and my expectation from this handbook. Thank you, but I really congratulate all of you on doing a wonderful job, and we will definitely go through the handbook on how to replicate and scale the smart grid deployment in India. Thank you.
Thank you so much, Ms. Anjali. I think you could very well have co-authored the handbook. We are very happy to be in sync with the regulators, and definitely a lot of the points that you did raise have been addressed in the handbook. Of course, we couldn't go into the level of details that you did specify are very much needed. That's exactly what we intend to do in the second phase of this project. And I think a very valid push from you on why we need to continue doing this. So in response to some of the questions that you posed, I'd now like to invite our next speaker, Professor Anup, who's also one of the platform experts who has contributed in the making of this, to probably give your views and probably respond to some of them raised by Ms. Anjali.
Thank you very much. So let me first of all congratulate the team for coming up with a very useful document that will serve a benchmark for the sector for evaluating the investments and policy and regulatory design as well. I do agree with a number of points which were just raised by the previous speaker, Ms. Anjali Chandra. One of the, of course, very important thing is that, she mentioned about the technological obsolescence. It's not just because the things get old, also because nowadays, there is this communication protocol and the IT interface, which gets obsolete much earlier. And that essentially forces the utility to keep on making this investment time and again. So the true cost, if you have to look at it, should be looked at more of a life cycle assessment basis. And in fact, very recently, we tried to do something for an investment which was done on a related kind of investment in Kanpur in certain areas. And there was some approach which was suggested, should we look at a short-term approach, looking at just a few aspects. But the broader aspect is that we should look at not just the direct but indirect cost, and direct as well as indirect benefits. And both of them needs to be identified. We may not be able to monetize all of them, or at least give a value to that, but at least we should identify what all those things that will go into the such investments, and that will help us realize the benefits thereof. But an important challenge is essentially not just making an investment now or in smaller pockets, but also ensuring that this becomes a part of the usual business decision, right? It's not something that's just because there is a recommendation coming and the experts have thought it's good. So how does it become part of a standard investment decision making? That is the ultimate objective, to ensure that we need not do these studies. We should become irrelevant, in fact, in future. I mean, that's what I would say. The academicians should become irrelevant. It becomes so much ingrained in their natural decision making that the companies start finding the value in such investments. For that, I think they should learn how to monetize the data that you will have. So they can monetize data in a number of ways. Of course, first and easiest thing is to understand the demand profile and how it varies across day and across seasons. And then perhaps that will help them design time of day tariff. And also to ascertain, for example, in some cases, if there are PV based interaction or storage which is there behind the meter, one should be able to understand what kind of value it can bring, not just in terms of energy or in terms of demand response, but the other kind of flexibility, specifically offering something as a storage solutions. But on the second aspect is not just the technological aspect, financial aspect, and the institutional aspect. Now, institutional aspects means that the such investments are to be handled by some individuals. There are people involved, and these people have been trained in the existing systems. Some of them are directly employed. Some of them are many times on a contractual basis, or maybe through other kind of means. Now, or maybe they are sometimes embedded in the investment horizon itself. Through the company who's supplying the equipment, at least for the shorter time period. But the need of the ecosystem is that there are trained staff who is able to manage this also. They should not be dependent on a technology supplier all the time. They should be able to even make a recommendation to their company that look, based on the learnings from these one implementation of pilot project in X area and then in Y area, then in Z area, we found that this is the things we should be implementing and taking it forward. And that will involve, of course, the regular capacity building. And I'm sure there are efforts being made, but that's something which should become part of the broader. And of course, from the regulators' perspective, many of these things should become part of the smart grid regulation as such, which have come up across some of the states, and we have also analyzed some of these regulations, which lays down a broader framework. How do you identify the benefits, and how do you ensure that the benefits are taken and accounted for? Last but not the least, the other thing is again from the regulatory perspective side, because as the study, it was being mentioned that the payback period was roughly about 3.5 years. So if something it has a payback period of 3.5 years, and the MYT control period is generally of a 5-year duration, everywhere now it's 5 years. So is it possible for us to at least start nudging the distribution utilities to make these investments, and which can give you benefits over a 5-year horizon? And then of course you can convince the regulator and get those investments also approved. I think I'll stop here. Thank you very much for giving me the opportunity to be here. Thanks.
Thank you, Professor. I was just prompted that we have the next session speakers and participants who have joined the session. You're of course welcome to continue to listen to our discussion. We're almost at the end of our segment. Sorry for the pushover from the inaugural that we have to bite into your time and space, but a little bit of patience is requested from the others. With this, I would like to now invite Professor Debajit from TERI, who was also a fellow expert on the platform and has been challenging us to think of things from a more decentralized perspective. And I would like to give you the floor now, sir. Professor, you're muted. We cannot hear you.
Thank you, Shweta, and thank you FSR Global and India Smart Grid Forum for inviting me and giving me the opportunity to share my thoughts here with the esteemed audience. I think, and I would also like to congratulate the FSR team for this very timely and relevant project report, which I think while reviewing it, I could also learn a lot of new things, this one, and also being part of the platform, this one helped me to get more nuanced about the smart grid issues in India. I think if we talk about smart grid or this one of the major thing that is that everybody is trying to address is the AT&C loss, and worldwide some figures say that $96 billion is lost in non-technical and commercial losses. In India, it's roughly about $23 billion. So it's a $2.3 billion. So it's a huge amount. So I think it's rightly that we are talking about smart metering infrastructure as one of the major components of the smart grid. But I would like to say that I think we need to go beyond the smart metering infrastructure to also consider other aspects of smart grid with equal impetus. This one in India, we are talking a lot about the smart metering, the AMI and other things, but I think we need to go beyond that to get full advantage of the smart grid system. We are not talking too much on those aspects. Some experiences that we have in implementing smart grid was in with support from NEDO in Panipat district in 4 feeders, primarily related to improvement of distribution reliability. Then reduction of the distribution transformer failure rate, basically by developing a best practice SOP, and also reduction of AT&C losses by incorporating different type of infrastructure, RF mesh and quartz technology. And what we have found is that from that in 4 years time, so we implemented in 2014-15, and we did some analysis in 2019 February, I think, if I remember correctly. Yeah, this one. So while initially the SAIFI and SAIFI was about 8 times per month, it got reduced to about 4 times per month. SAIDI from 23 hours per month to about 12 hours per month. DTR failure rate was about 15%. We could reduce it to 10%. This one, of course, the target was 5%. This one, and AT&C losses was about 35%, and it got reduced. So the target was 15%, and it has reduced to about 18% now. But of course, while doing so, we faced a number of challenges while implementing this project. And some of those challenges, and some of the earlier speakers has also mentioned about them, developing the right baseline data. This one now, that's the biggest challenge. That means unless you have a correct baseline data, then you won't know what exactly is happening. This one, and in most of the discoms in India, the data generation, of course, is a tough task. Now, I did my PhD on rural electrification and collected and tried to collect a lot of data from different agencies. And strangely, I found using the performance of the utilities report, the TND loss and the AT&C losses are actually intersecting at a point. This one now, TND loss is always lower than the AT&C losses. This one, so it cannot intersect. So either of the data is not correct. So I think that's something that we probably need to work much harder to get more benefits. The upfront cost, interoperability of the systems. I think some speaker mentioned about the obsolescence of the communication systems and capacity building of utility officials. Some of the utilities do undertake capacity building program, but I think unless right from the CEO to the lineman or the line person, this one everybody's vision is matching, or at least it will be difficult to implement such type of program in a government-run utility. I can understand Mr. Ganesh Dash is there. Tata Power can definitely implement it. This one, but then in a government utility, the CEO's vision and the line person's vision also have to match. You have to communicate that through change management program, and then only probably this one the results will be much better. This one we have seen this earlier also in case of in case of the franchisee distribution, involvement of the franchises for distribution management or the UDAY programs. How this one. So probably this is something that we need to take into account. Definitely there is need for regulatory framework for smart grid initiative. Political economy challenges are there. You know, election time, a lot of people's parties start talking about free electricity without specifying what exactly is going to be free and how it is going to be free. This one, so there is so the consumers feel that okay, anyway, my electricity bill will get waived after some years. This one, so these are some of the challenges, and I think another important but not much talked about challenge is the impact of the introduction of smart meters on the consumer behavior. So I think we talk a lot about the technical side, but going beyond technical side, the consumer behavior and social aspects also need to be taken into account. And this is a completely less researched area, at least from in the distribution sector, in the technical, as far as the smart grid is concerned. So I think this is something that probably need to be considered. One thing that I would like to suggest, and I think I've mentioned it in my comments in the report also, that I would have loved to see that the report also covers some aspects of the mini grid. This on how we can actually interconnect mini grids with the main grid. This one, and what could be the possible this one benefit out of that. I think in Tata Power probably is doing something of that sort, but I think this is something that we need to talk about much more than what we are doing, because I see 5 years down the line, 10 years down the line, the way well everybody is talking about the 3D framework of decarbonization, digitalization, and all these things. But I think democratization of the grid is something that the peer-to-peer is something that probably in the next 5 to 10 years time, no matter how much one would not try, it is going to come. This one, and that might lead to the deregulation of the markets, and probably it will try to create the electricity market. It might take time in the rural areas, but definitely it is going to happen. In Bangladesh, it has started to happen. This one, so in India also it is going to happen, and so I can see the electricity structure in a way that mini grids which are interconnected with individual DRE system, which are then connected with the main grid, both for taking and feeding electricity to the main grid, probably is something that we might have in the future. And we thus need to work towards that, so that we don't suddenly it will come and suddenly technologies will change and we'll be in a loss at that time. So I think we need to start working on those lines. And of course, consumer behavior and social aspects also need to be provided equal importance. This one, if not more, along with the technical side. This one. So I will stop here. This one. Just like to add, and this is something that in Europe, I think under the EU Horizon 2020 program, this what they call it community energy system. This interconnected grids are taking shape in many of the countries. I am part of one such program, which is led by University in Ljubljana. This one, and many such projects are coming up in Europe. So probably in India also such type of things is going to happen in future. Thank you. I will stop here.
So much, Professor Devajit. I think a very important point that you did raise at the end, the democratization of the grid is something we cannot ignore. And we will definitely bring lessons learned from the global experiences there, because luckily the Florence School is also the chair of the IEA peer-to-peer platform. And Professor Gleshaw and his team are sort of putting together the observations from there. And going forward, we would, of course, like to link the lessons learned from the different platforms at that level as well. So definitely point taken, and also on the social behavioral aspects, especially for India, I think it's going to be a complex and challenging study. I hope we will add this to the next phase of the project, and hopefully we get the kind of support and resources to do that. With that, I would like to now invite Mr. Ganesh Das, who would give us his view from the utility perspective. We have heard from the regulators and the academicians. Now for the utility that actually does the hard work. And after that, we'll move towards the closing of the session. Mr. Das,
thank you, Shweta. Good afternoon, good morning. This is very interesting because I was just going through the book, and it really translates what we have been doing as a part of our experience, what we have been trying to learn through a difficult process of experimenting with technology. It is there, especially in this space of operation technologies and IT technology. And we have also witnessed convergence of these technologies since few years on this. Now what we are doing is we are actually moving to a platform approach, because there is a what we are seeing, which we did not see since some years, is earlier we used to buy a technology and the technology used to stay for some year. The entire focus and the energy used to go in implementing the technology. Now what is happening is there are multiple small applications are coming in, and especially mobile applications, and anything related to a smaller version is either developed internally by the utility, or there are some players, startups also, who provide that technology. So what is very important is to how does this entire thing get integrated into the larger technology landscape. And that is where we have a option and opportunity to make into a platform approach. And possibly, Shweta, I feel that is something which we also feel somewhere needs to be put in as a futuristic thing. Then how do we really have some sort of a plug-in play system into the entire technology landscape when it comes. And if you typically look at the again stressing on the basic things, whatever technology we choose to implement, but the major thing is the foundation technology has to be, we have to get them right. For instance, a GIS has to be the best. We have to spend more time in making sure that the GIS is accurate. It captures all the consumer points. It captures all the critical assets. It captures all the critical health of the assets, and it is integrated to a maintenance and a production platform, so that you are very sure that where exactly it is located, how then subsequently it can help you to address the challenges of breakdowns and maintenance, etc. on that. Then we definitely have the SCADA sitting on top. And then when you're talking about SCADA, it doesn't help there, because at 11 kV or a sub-transmission monitoring is not the only thing. Maybe at the consumer level, we heard in the earlier sessions talking about demand response. And when demand response and all those things will have only a strong relevance when we talk about, we understand the low voltage consumers better. So therefore, an importance to have an outage management system wherein the CRM and all related transactions at the consumer level is connected in some possible way, to also kind of take it to the billing platform also, so that some of the information which has been experienced or some of the experience of the customer for the month can be also translated and conveyed to him through the bill. And today we are also having an opportunity to convey through electronic lease, and there is an opportunity to convey this information on a regular basis through the electronic. And if you, whatever you say in India, the AT&C part, Devajit also mentioned about the transmission distribution and AT&C. India is going to always kind of monitor the AT&C losses. And I personally feel that this is one of the best ways you can really monitor efficiency at the grid. And nowhere in the world, the way India measures AT&C, nowhere in the world they do it so efficiently, which has a component of billing efficiency, collection efficiency, and also considering any leakage in revenue which happens through theft, etc. On that, this happens in many countries, including so we call typically the developed countries. Also, I have seen experience theft happening there also. So how do we really work around that? And this assumes a lot of importance because energy audit becomes a very key role. So different layers of energy audit, how do we use technology to make sure that energy audit is very clear and spec and clean is also extremely important to do that. And this assumes importance because we have business centers, profit centers, and energy audit helps us to be making sure that every unit is making profit and monitoring the energy transaction in the appropriate manner. The next point, which I would say is important to understand, is from the smart meters. The smart meter implementation is one side, but are we only limiting the usage of smart meters to reading the meter and looking at the reading, or can we using it for other applications like low voltage automation, improving the efficiency, giving some value added service to the consumer, integrating that with the solar, platforms, etc., rooftop solar, and then create a business case for setting up a solar rooftop at a consumer premise. And I think that part needs to be talked to in a very big project. And we are doing this Electrics project, which is a factory in India, which is funded by the European Union and with our partners, NADS, ODT, GECO, Schneider, and it is reaching its conclusion, and we are hoping to demonstrate everything here. Demand response is going to play a key role. And what I would like to make conclude by making a statement that while we do all those things, regulatory changes are extremely important, because if you look at, we don't have a great time of use, regulation coming in. We don't have a critical peak pricing. This all encourages, usage of technology in a much better way. Performance-based regulations are not there to that effect. We don't measure SAFE at a low voltage level because low voltage automation production is extremely limited, and whatever low voltage we call does not really capture the, measuring the consumption and everything at that level. So how do you do that? And 95% of our consumers are connected on low voltage. The electric vehicle which is going to come in are also going to be connected to the low voltage. How do we do that? And finally, what I would like to make a statement is technology and innovation. We always make some sort of a mistake, and we have also done it here. Is we try to improve step by step. I recall a case when the color TV came to India, people, or the black and white television, there was a big boom. Many people have started putting black and white television tubes factory. One company, there was a research organization, I believe in Chennai, they come out with a statement that instead of black and white TV, we should put up color TV because this is not going to have a market. Exactly that is what happened. All the black and white picture tube TV companies vanished, and the colored picture tube came in. That technology leapfrogging. India has to look at not what has been happening in the other parts of the world, but how do we really understand from them, learn from them, also look at the next level of technology which could be implemented here. And the learning we have observed that with European Union as well as with many countries, it is becoming now two-way. It is not that India is only learning, but we are also sharing a lot of experience. And thank you. This is what I thought I will share in this short discussion. Thank you.
Thank you so much, Mr. Ganesh. I think what was super nice for me to see as the moderator is that all these stakeholders were in sync and we're actually complementing each other. So we are in line to achieving our National Smart Grid mission. I think then I will take the liberty of troubling each of you for more details and participation as we go along. So to close the session, I would like to finally invite Matthew Craig from DG Ener, who has been the person instrumental in getting this off the floor for the last 5 years that we've been engaging with him. So Matthew, the floor is yours.
Thank you very much, Sweta. Do you hear me?
Yes, we do hear you.
Okay, fine. Well, yes, Sweta, I think your last sentence was really to the point, that all the main stakeholders that we heard today are really in sync, and we had a very informative session, which was in fact pointing to or giving us really some good insights on how to take this forward. And as Florian said at the beginning, but also Mr. Mishra, there's really consensus that we need continuity of this work. And there is also a consensus that we really want to have, or to get to the stage of really use and uptake of this handbook, and also look at it, how it can be used in the different contexts in different states in India. It's very important to also repeat again what is the spirit of this work. Professor Glachon talked in the beginning of this sharing of knowledge. Mr. Mishra also said that India will have to find its own answers, and that's of course fully true. Also, you said, Sweta, that India itself is of course a vast area in which certainly not one size fits all. That's why I think it's important to really, in the follow-up work, now we would really go to the level of states in India and tune the use of the handbook to those different contexts there. We could think of really working in a number of technical seminars, in workshops in the different states, see how the handbook can be used there. Following up on the use cases that have already been selected in the handbook to look at it in more detail. Following up also on some of the let's say geographical areas where cases have been studied, Gujarat, Tripura, but also I understood well from Ms. Chandra that there is interest in Punjab to look at how the handbook can be used. Very important was also what you mentioned, Sweta, that we should not only focus on the states, the areas of India where the situation with smart grid infrastructure is already quite developed, and where the states are already quite advanced with deploying smart grid applications, but also going to states where initial steps are taken. I think in some of the more technical contributions to the discussions, we heard very much the value of the methodologies of CBA, SRA. So this would be really helpful for the utilities, for also decision makers in the states who finally have to take decisions on those investments. It's important, I think, there also to recognize the different levels or the different perspectives from which these methodologies, also like CBA, can be used. Yeah, so important is to also bring, for a policymaker, to bring in the calculation, the societal, the environmental impacts, but we also have to look at who in the end takes the decision on the investments, and is this, how informative is the CBA for them. In many contributions to the discussion, we also heard the importance of involving the end consumer, the customer. So I want to point to a session that we will have tomorrow as part B of the EU-India Smart Grid workshop, where we exactly will look at more local energy communities, social innovation, and so on. And I think this also links with the remarks that have been made on the democratization of the grid and all the potential that is there. The focus also on mini grids. So this will be, or we will zoom in on projects in that area in tomorrow's part B of the workshop. And so you're very much invited, welcome to join that session there. So let me finish by thanking all the speakers and also you, Sweta, as a moderator here in the event. Also, a big thanks to all those who contributed to the handbook, and just to really confirm again that we are very much Looking forward to the uptake, to the use of the handbook. We will look in the frame of the EU-India Clean Energy and Climate Partnership how we can support this, how we can also financially further support this, so that this valuable result is really taken up. And of course, we are very much looking forward to work on this together with the National Smart Grid mission. So with this, I finalize here, and big thanks to all, and hope to see you in many numbers tomorrow in the part B of the EU-India Smart Grid workshop. Bye-bye.